In this video, we will be reviewing the basics of probability. In class, you'll be analyzing many experiments with many possible outcomes, and in later videos, we will cover the types of experiments and the corresponding probability distributions. But for now, we're going to spend some time just going over and reviewing the basics of probability. This material can be found in Chapter 2 of your textbook, Probability and Statistics for Engineering and the Sciences by J. DeVore. First, let's talk about sample space and events. The sample space is going to be the set of all possible outcomes of an experiment. And an event would be the subset of the sample space, what actually occurs. And a simple event is where you have one outcome at a time, and only one possible. Compound events can contain more than one possible outcome. So if you have an experiment that can possibly have two possible outcomes at the same time, that would result in a compound event. It's essential that you know the difference between intersections and unions and to keep that straight. The intersection of two events, in this case let's say A and B, means both occur. A and B happen, represented by what looks like the upside down U character. The union of two events is an OR symbol, means that A happens or B happens. The complement of an event, let's call it event A, is represented by A prime, or the set of events not contained in event A. This leads to the probability that an event and the probability of its complement will sum to 1, because that contains all possible events. When two events, A and B, are mutually exclusive, the probability that they both occur, for example, A intersection. When two events, A and B, are mutually exclusive, the probability that they both occur equals the probability of A occurring plus the probability of B occurring. And this means that the intersection of the two, the probability of A and B, is equal to 0, because only one can occur, which is what mutually exclusive is at the core. And when two events are mutually exclusive, the intersection is represented by the formula you see in the middle. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. And if you think about a Venn diagram of the two events happening, what the last term of this equation, the A intersection B here, that is keeping the middle, the overlap of the Venn diagram, from being double counted in the probability. And of course this gets a little more complicated when three events are mutually exclusive. As you can see from the formula on the bottom of your screen, you not only have to subtract out the double counted parts, but you also have to add in something that's been subtracted out one too many times. Next, let's talk about permutations and combinations. A permutation is an ordered subset, which your textbook denotes using P sub k comma n, where n is the number of events and k is how many you're choosing from it. This is calculated using the formula n factorial divided by n minus k factorial. Examples of permutations include picking the first, second, and third place winners in a competition, or choosing football players based on their position on the team. A combination is an unordered subset, which your textbook denotes as n choose k. This is calculated using the formula at the bottom of the screen, n factorial over k factorial times n minus k factorial. And examples of combinations are something like picking the best TV shows with no particular order, or choosing marbles at random, or picking dodgeball players. Dodgeball, unlike football, has no positions, which means that order isn't important. Often, you'll see events that have different probabilities of occurring based on another separate event that occurs. These are called conditional probabilities. And here you can see that the probability of event A conditioned on event B can be calculated using this formula. The probability of A given B, that's how that's represented, is equal to the probability of A and B occurring, the intersection of A and B, divided by the total probability of event B. And many times these probabilities will be represented in a table like the one you see on the right, showing the events and their complements and the conditional probabilities inside the table. And this leads to the law of total probability. Again, we have an event. This time we'll say that it's event B, being conditioned on a series of events, A sub 1 through A sub k. And to get the probability of event B happening, the conditional probabilities are multiplied by the probability of A sub I and summed for all the events in series A to give us the total probability that event B occurs. Conditional probabilities can also be calculated using Bayes' theorem, as shown here. The probability of A given B is equal to the probability of B given A, multiplied by the probability of event A, all divided by the probability of event B. The important part of Bayes' theorem is that it converts test probabilities into real probabilities. For example, a cancer screening test will have a certain percentage of false results, either telling people they have cancer when they don't, or vice versa. Which is obviously, a little bit risky. And so Bayes' theorem allows us to say that with a test result of negative, then there is X percentage that you are actually cancer-free based on the accuracy of the cancer screening test involved. The last thing we will review in this video are independent and dependent events. You should be able to identify these fairly easily. The probability of a dependent event is related to the probability of a separate event occurring, indicating that it's dependent, on those two. The probability of an independent event is not influenced by any other event, hence the term independent. And to say this mathematically, you can use these two statements. A and B are independent if and only if, that's the IFF you see there, the probability of A and B occurring is equal to the probability of A multiplied by the probability of B occurring. This can also be stated as the probability of A given B is equal to the probability of A occurring, since if they are independent, they'll have no effect on each other. And this has been a very brief review of some basic probability concepts that will help inform statistical concepts covered in class. Again, this material can be found in your textbook, Probability and Statistics for Engineering and the Sciences by J. DeVore in Chapter 2.